Okay, the first one is basically highlighting the life cycle of data and how data created, and data versus information, and characteristics of the data and information. Those are basically we call fundamentals. So, what is data basically? What are data? So, can you remember the
Data,
definition?
yeah, data are the things which is not in a proper format.
Yeah, unorganized. So you can say
Yeah, no.
unorganized. So basic raw facts about something, someone, or some concepts. It's highly disorganized. So you have large amount of disorganized things in the world, right? But so you have to take these disorganized things, or you have to take these unorganized things and organize this in a proper manner where you can use that for take decisions, and where this information where you can create information which are useful and meaningful. So that is the process of data processing. So you take the unorganized thing and make organized things. So that is the process. So that process is basically called data processing cycle. So let me show a small brief introduction to that. And if you go to, right, let's take the fundamentals. And in the fundamental chapter, so basically we will be learning, okay, here you can see. So data, so it's raw facts about something, someone, or some concept. So information, in the other hand, it is processed data or meaningful data, right? Process or meaningful data. So I'll send this note to you, so no need to write down anything, right? Just so see the comparison. So data always it's less meaningful, and but meaningful information is meaningful. Value, if you take data, has less value and more value on information and decision making. So since this is unorganized, it is not good to use these unorganized things to take decisions. But once it is organized, or once it is processed, it can be easily used for decision making. You can make decisions on
Yeah,
that, right? So then an action motivator, what is an action motivator? So what is that?
to do something.
Yeah, to do something, you it will be motivating you to do something, right? It will be
Yeah.
motivating you to do something. For example, let's say so we have recently so that the Chinese rocket debris was falling to earth recent, so
Yeah,
this
yeah.
last weekend.
Indian Ocean.
So yes, people were really eager on that, so where it will fall, right? So whether it will fall to so our land, or whether it fall to some other place. Likewise, people were, so people, we have actually some people are like tracking that live, and so that is action motivator because of that information, and
Yes.
finally it fell down to the it fall down to the Indian Ocean.
Yeah.
But so that is also an action motivator. That information itself an action motivator. People are searching whether we can find any footage. So I was even searching
Mm.
whether we can find any
Yeah, I saw
footage.
it in your channel.
Right? Yeah. Okay. Then after found that, I uploaded that, and then
Yeah.
value is consistent over time. So that means, so whatever we found, whatever I found, even when I upload, that has a value. But after that, so it
One
doesn't
week,
have
two
much
weeks.
value. So it's
Yeah.
diminishing, right? It's changing with the time. For an example, when we
Mm.
won the World Cup, so it has the highest value. But after
Mm.
some time, so you know that now it's not much valuable, right? It's just a
Yeah.
fact. It's valuable, but not much, not that much, right? And the organized and unorganized things, I have given red. Red is a color, but see how it is organized. When it is a red data book, is it a color or something else?
Something else.
Something else. It's not a color. So here, red, if you
Mm.
take alone, it's a color. But if you take red data book, it doesn't mean a color. It shows the endangered species, right? It
Mm.
shows the it's a book with endangered or vulnerable species in the world,
Yeah.
plants and animals, right? Then so that is something else which can be used to take decisions, right? So when people are trying to build highway, so if this endangered species is damaged, so people are shouting on behalf of the endangered species, because
Mm.
so that is important to us, because if there are few left in the earth, it's in the red data
Yeah.
book, so we have to protect, preserve. Okay, then you have in the A level something called golden rule of information. In this golden rule of information, it says that value of the data will be diminishing over the time. So it has highest value at the creation time, but with the time, it will be diminishing back and it will become less valuable. When it becomes less valuable, it will again become a data to some other process.
Yeah.
Understood? So initially it's
Yeah.
information. For an example, election results. It's information. So we have like provision-wise election results. We will analyze candidate-wise results. Likewise, we analyze everything. But let's see, after 5,000 years, election is just a fact in a history book, right?
Yeah.
Election will become just a fact in a history book that by that time. So that is the nature of information. It has the highest value, but it's diminishing. That is called the golden rule of information. And
Yeah.
then the abstract model of information that
So we
shows
did
how
this.
data is processed. Data is taken, processed, and
We,
information is
we did this.
with the time. So it will be diminishing and it will become data again. And this is a cyclic model, and this is called the abstract model of information. Right? Abstract model. That means any information system work according to this process. Computer captures data, process it, produce information,
Output.
and that information will be given as output. That output will again become data in some other process. So you can process it and produce information. Likewise, this is a cyclic model. Okay, right.
Yeah.
So that is the basic. And then we have to learn about a system.
So we did this part. Sir.
We did this part, right? System,
Yeah.
and yes, also
Always
computer
we did.
system. And so
Until
system, so basically, yes, let me remind. So system is a set of interrelated components work together for a common goal. An information
yeah.
system is also a system. Computer system is kind of information system, so which does these tasks: capturing, memorizing, processing, storing, communicating, and output data and information. So that is the way how this information computer system works, right? And it is
Yeah.
also having a different parts like hardware, software, and liveware. And hardware can further divide. So according to this is called von Neumann architecture. Have we explained that previously or no?
Uh,
This is called von Neumann
the one
diagram.
human thing. No,
No,
we didn't do the one.
sorry.
And that picture, yeah, the picture we have, I have written. It's a block diagram of computer.
Yeah, block diagram, sometimes called von Neumann diagram. This is why because the von Neumann person called von Neumann, John von Neumann, he has suggested this model that earlier like it was like data process output. So when it comes to this Charles Babbage suggestion, it was like data process and output. But so von Neumann suggested the stored program concept. That means things can be stored in a memory, repetitive task. Otherwise, it's a hassle, no? So time to time, we have to give instructions again and again. Time to time, we have to give instructions again and again, and that is a problem. Therefore, von Neumann suggested it is possible to store information for long time usages. That means store instructions, sorry, not it's store information, store instructions. That means if task is repetitive, you can use same set of instructions to process that data. For an example, think
Yeah.
about MS Word. So MS Word has some repetitive tasks: typing, writing, inserting, editing, formatting, some repetitive tasks. Those repetitive tasks are stored in the permanent memory. Then it will be loaded to a temporary or main memory. Then you can use that instruction to process any data anytime. Understood the advantage of one human architecture. You can store the concept, you can store the program. Okay. That stored program will work on data and produce information. Clear on this?
Yeah.
And so may I know what is stored in RAM, what is stored in ROM? Both are belongs to main memory, but what is stored in RAM and what is in ROM?
RAM is the currently running applications and its data.
Yeah. ROM?
ROM is like the hardware. The main thing is the drivers and stuff.
Yeah. basic drivers installed by the manufacturer. Anyway, firmware. ROM stores firmware. Firmware means
Yeah.
the software stored at the manufacturing plant.
Mm.
Right? Software stored at the manufacturing plant. Basically, BIOS, basic input output system, is a firmware. It's in the ROM. Right. BIOS in, so
Yeah.
what is the task of BIOS? Can you remember what is the task of BIOS? Basic input output system.
It's to like control the whole PC, you know.
Yeah, it control and configure the main basic hardware. It control and configure the main hardware,
The main. Yeah.
right? Or basic hardware. Then, so all the configuration like date time settings, hardware configurations. So user can configure them. Button to do that, right? To do that, user must store that configuration. But configuration, the issue of configuration. So configuration cannot be saved in the ROM. So what is the reason? Configuration cannot be saved in the ROM. The reason?
Because if it's wrong, everything will be upset.
Sorry?
If it's wrong, everything will be upset. Like the output won't be proper.
No, that is not the fundamental reason. ROM is what? ROM stand for?
Read-only memory.
ROM stand for read-only memory. Then, can we store something in the ROM? Since it is read-only.
No, only reading.
So it's difficult, no? It's read-only.
Yeah.
So then, the BIOS is there in the ROM, that is stored by the manufacturer. Drivers are there in the ROM, that is stored by the manufacturer. He can store because that is the manufacturing plant, but we can't store. Therefore, there's an additional chip supporting ROM. What is that? There's an additional chip supporting ROM. Additional chip supporting ROM. What is that? That is called CMOS. CMOS, complementary metal oxide semiconductor. That is there in the
What?
motherboard
CMOS?
also. Yeah, CMOS, complementary metal oxide semiconductor. There's a relationship between this ROM chip and CMOS chip. So basically, let me show this. ROM is also called ROM BIOS. The reason is ROM is also called ROM BIOS. The reason is it stores BIOS, right? This is the chip, ROM BIOS chip in the motherboard. You can see the ROM has BIOS in it. Yeah, in the motherboard, this is a special chip. This is how BIOS looks like, right?
Yeah. F2 or delete key.
Yes. You have to press the special key to access the BIOS. Press F2, F to access setup. Likewise, it instruct. So anyway, you can see this kind of sticker. So this says inside this ROM chip, Phoenix BIOS is there, right? Likewise, the ROM BIOS here inside this ROM chip, AMI BIOS is there. AMI is the BIOS manufacturer. Here, Phoenix is the BIOS manufacturer. So likewise, there are different BIOS manufacturers. Anyway, so BIOS is a special program in the ROM. But the ROM cannot save the configuration. When you do the configuration, when you do some changes, for an example, you can edit data. You can edit the date time. You can also edit the boot in order, which device to come first, whether CD, DVD, or pen drive. That boot in order can be changed. So
Install
how to
Windows
turn on
also
the
we should.
computer, and you can change the fan speeds. You can change. You can set a BIOS password. So likewise, you can do more. But you can't save all these things. Nothing you can save it in the ROM, because ROM is read-only. But there's additional chip support in that. That is called CMOS chip,
CMOS.
complementary metal oxide semiconductor. And that is a sub here. This you can see attached to the ROM. There's a different chip. Here you can
Sure.
see.
Could you give that as a point so I can?
So you need to write down that.
Yeah, because I
Okay,
didn't
I'll
write
give
that.
you right. Okay, now you can see this is a BIOS chip. BIOS chip means the
Yeah,
ROM chip. And in the
actually.
chipset, inside the chipset, so you have that's a ROM chip, CMOS chip. So that is
Mm.
attached to the chipset. Chipset means the main chips controlling the motherboard. So you
Yeah,
have BIOS chip, and in the chipset you have CMOS. To charge the CMOS, to keep the CMOS alive, you have CMOS battery. Some people think that in this storage is done in a battery. No, battery is why. Why battery
power,
is there?
put up those startup
Because
powers, right?
that is the yeah. When you even you turn off the PC, even you turn off the computer, still your date and time is running. No,
Mm.
right? How? Because you can remember these settings in the CMOS chip. How? Because this battery provide battery power to the motherboard. So using that battery power, it remembers. Right? That is the process. Right? When this CMOS battery is dead or damaged, what will happen? You used to forget date and time and all the settings. Telling always press F1 to reconfigure or press F1 to continue.
Yeah.
Or please go to the setup
So,
and
but nowadays it gets synced with the internet. No?
yeah, but when that is or after the after you turn on and boot up to the operating system, no.
Uh,
But before that,
yeah,
before you turn on the mesh, before you boot up into the operating system, so you have to control that. So you have to keep the time and date. So that should be done with this CMOS. So this CMOS battery cost you only around like 1,000, no, 120 rupees.
or normal that
Yeah,
normal
normal
size
that
battery.
it's normal kind of this small battery.
Yeah.
It only it only cost you small amount, right? Cool. Right. So let's go back. Right. So here you can see the random access memory. Right. The usage of random access memory, as I said, it is dynamic RAM. Right. It is also called dynamic RAM. The reason is you need periodically refreshing to keep this memory alive. That means you are reusing the same thing. So it's similar to that, something like that. So let's say you have there are two students and they are having one cap. Two students having one cap, right? So what happened if they share this cap? 1 second, it's with one student. So
Mm.
then it's with another the second student. Again, the first student. Then the second students. Likewise, if they share. So can you see that? Can you observe that?
Yeah.
Yes. So what happened if it is like 1/10 of a second? 1/10 of a second.
Uh, can't,
Still, you can see that, right? So
we
what
can see,
happened?
but yeah.
Yeah. What happened if it is like millisecond?
Then can't only obviously.
Millisecond means like 1,000/1. So that is so too faster.
It's
So
a fast.
similar to a rotating fan. If a fan is rotating, you cannot tell exactly how many
Counts.
fan components are there,
Points.
fan slips are there. So you can't tell that.
Mm.
And how many wings, likewise, you cannot tell. So, but when it stops, you can count.
Yeah.
So, have you seen this? The tires and the bicycle tire. There are some. So what do you call them? So
Rims.
BICYCLA
Rims, right?
bicycle ring. I think
Rim, RIM.
yeah, ring. These are called like. So what do you call fork rings or I cannot.
No, rim, no, RIM, no.
Yeah.
RIM. Yeah.
So then, yeah, bicycle rim. So what this? I cannot remember exact wording for that. You have some. Okay. So what these wires are called? These wires. So what is?
Oh, that wires.
I cannot remember the exact wording. Sorry, so I forgot suddenly. Anyway, so can you count this number of lines when it rotating? Can you count this and tell?
no, no.
So because you can't count, right? You can't count.
Yeah.
So, but when it stop, you can count.
Yeah.
So when it is too faster, we can't measure, right? For an example, if this cap is exchanged between two parties, if it is too faster, then when you observe, you can see cap is in both heads, right? That is what you can see. There's a cap and cap. So both are having the cap. So similar to that, when RAM is refreshed, so it is periodically assigning, and actually this is called time sharing. So periodically time sharing with some other applications. For an example, the word you will run for 1 millisecond. 1 millisecond you will display the time, date and time. 1 millisecond you will display taskbar. 1
So
millisecond. Sorry?
were you saying spoke?
Oh, yes, P-O-K-E-O.
Spoke.
Spoke.
S-P-O-K. S-P-O-K.
S-P-O-K-E. Yes, spoke. Yeah,
Yeah.
spoke. Yes, okay. So whatever. So this 1 millisecond, likewise, you are changing the task each millisecond. 1 millisecond you give it to Word, 1 millisecond to the taskbar, 1 millisecond to the quick launcher, 1 millisecond to the mouse. Likewise, you share the time with each application. This is just an example, right? Just an example. But you can see all are running. All are parallelly running. But to keep that, you have to periodically refresh your RAM. Periodically refresh the RAM and keep it refreshing. So we want to see the change. For an example, in monitor also that refreshing part is there. Basically, it will light up only one bulb or one row at a time.
So that's why it's called 60 hertz.
Yeah, 60 hertz. Likewise, 60
90,
hertz means
120.
each pixel. So this circle, so this is Z-like circle. This is Z-like circle. That means it's go this way, come back this way, come back this way, come back this way, this line, come back. All lines will be accessed, and that will happen. That whole process will happen 60 times per second. See how fast that is. The entire process will happen 60 times per second, 60 hertz. Right? But when you point a camera at your monitor, you can see some lines. Have you seen?
Yeah.
That's the reason is camera has a frequency and TV or this screen has another frequency. When this frequency overlaps, it creates some overlapped frequencies. That's why you can see some lines, right? So it's this because of this frequency overlapping. So anyway, this monitor is also refreshing, right? Only one row or only one bulb at a time, but it is continuously changing. When you do IoT, you will understand that. IoT will when you light up one LED bulb, then another next second you will lighten up another LED bulb. So you interchange the power between each LED. You make it faster, like so similar to 1 millisecond for one bulb, 1 millisecond for another bulb. So when you observe, you can see both bulbs are turned on. And both bulbs are turned on, but actually not.
Yeah.
Actually not. Because of the frequency, you can see that. So I heard that so some people, so even so what we can see the objects, so that is in physics, right? Objects we can see the reason because the frequency of the object, right? But actually, so some people, so there are some like animals, or maybe theoretical or whatever. Sometimes you can call gold or anything. So if this frequency is so low, if this frequency is too high for their frequency, then they can travel through the object, right?
Yeah.
That is possible. So the reason is the wall we can see that as hard because of that frequency, because our frequency and the wall frequency, so it's relative, right? Relative to our frequency, wall frequency is too low. So we can feel that as hard, right? So related to our frequency, air frequency is let's say it's high. I don't know, high or low, whatever. So let's say related to our frequency, air frequency is let's say high. Then we can go through the ano. අපිට යන්න පුළුවන් වාතය හරහා. No issue. No. Understood?
Yeah.
You can travel through air, right? Will air stop you? Kulang wawa namatkanawada? Will air stop you?
No.
Traveling? No.
No.
You can go through air. But air is on another object. There can be some animals who cannot go through air. Air is blocking them. There can be. Because they are related to their frequency, air is like a solid. Right? Everything is relative. So related to our frequency only we see this world. But related to dog's frequency, it sees some other world. Related to bird's frequency, it sees some other world, right? That is the nature.
Yeah.
Related to fish, it sees some other world. So there can be invisible animals or invisible living beings related to their frequency. They see some other world, right? So it all depends on the relative frequency. Okay, because of the relative frequency only, we can see this monitor is turned on. Sometimes if there's a very fast frequency body, he can see these lights are rotating like a Knight Rider circuit. If his eye frequency is too, yes, can be, right? So if his eye frequency is too high, so if it can capture like fraction of a second, 1 millisecond, if I can capture, if his or her eye can capture 1 millisecond fraction, then he will see what is this. So this is like rotating bulbs. They might think this as a, right? Because but we can this as a solid screen, no? We feel this as a solid screen, but not for all. This is relative frequency. Anyway, so RAM is periodically rotated, periodically refreshed, and keep its memory. But there's another type of RAM that is called SRAM, static RAM. That SRAM is not periodically rotating. That's not changing. That's a fixed memory location. So that will be costly. That means you shared one cap between two parties. Both parties, it seems like both parties having cap. So then you have to spend for only one cap. But physically, if you get two caps, it's expensive, more space. And there's another RAM called SRAM. The static RAM is there inside. Which static RAM is there inside? Processor. That is called cache memory. Registers.
Yeah.
Right? This cache memory and registers, yes. Not ALU. This cache memory and registers these are static random access memories. These two components, SRAM. These component, DRAM. DRAM need refreshing, but SRAM can keep the memory without refreshing. Therefore, it's costly and it's hard to implement. Okay, so now you know about the RAM, DRAM, and ROM. Here I have indicated that CMOS thing.
Yeah.
Just read it. So when you change the BIOS settings, it's not possible to save those settings ROM because ROM is read-only. Therefore, ROM uses a special chip called complementary metal oxide semiconductor CMOS to keep the user preferences and change settings. CMOS chip uses small battery supply to get the supply voltage, right, continuously. Okay, that part you should remember, right? That is related to hardware. And then CPU, central processing unit. So this is similar to the brain of us, and there are three establishment or three implementations of this. The first implementation is called PGA. In PGA, pins in the processor, the surface is touching the processor. Pins in the processor and surface is touching the processor. This is this is LGA, land grid array. Pin grid array has pins. And there's another one, BGA. BGA is basically coming on ARM processors. What is ARM? Mobile. ARM processors means this mobile architecture.
Oh.
So you know this tabs, mobile phone. They are having like soldered like fixed processors. That is BGA processors. And PGA processors was the oldest one. LGA was the recent. PGA has pins, but LGA has a LAN. Right? It's landing on the pins. Okay, got the idea? This is landing on the pins. So pins in the motherboard, this is landing on the pins. But PGA, holes in the motherboard, pins are connecting to the holes. BGA
Why
is
did they
like
change?
embedded.
Why did
Sorry.
they change that? PGA to LGA.
So basically, when you remove the processor, what will happen? There are high chances to damage these pins.
Yeah.
And processor manufacturing so will be complex because processors you need to change. Motherboard, like it's really you change, right? So this is also related, right? Both are really, you are changing really, but so more priority to the processor. Processor, sometimes you have to remove and plug. So when you remove and plug the processor, if there are pins, it's inconvenient. No? So can be damaged. Considering that, this LGA and LGA, so this can be like included large number of surfaces too, and easy to production. All these things are considered. So when introducing this BGA is basically, so you want to embed that, so you don't want to remove that time to time. You keep both together. Okay, so you can see LGA, PGA, and BGA. And so I have just added note, but this part you won't get much questions in the exam. And then the next thing is the multiple core processors and single core processors. This is based on the number of ALUs, number of arithmetic and logical units inside your processing chip. Anyway, chip is a single unit, but inside that there can be multiple ALU units. It's similar to one kitchen and multiple chefs. Right? If you have multiple chefs, it consumes a lot of power, it consumes a lot of resources, but it will be faster. Right? If single core processor can, like, if you have a single core processor with the battery, if you can run this computer for let's say you have a laptop with the battery, if you can run this single core processor for let's say 5 hours. If it is dual core, then battery time will be reduced like 3 hours. If it is quad core, it's only 1 hour, 2 hours. When you increase the same battery, right? But you have to increase the battery as well. Then, if you are increasing the number of cores, you have to increase the battery too. Otherwise, it will shut down. It will turn off early.
Yeah.
Right. So other than the quad core, what you have hexa core, octa core, right? So even 10 core I have seen, 16 core I have seen.
Yeah.
Yes. Normally not used in our personal computers, but there are
supercomputer, right?
Sorry.
Supercomputer.
Yeah, supercomputers and gaming computers also you can use.
i9, those things.
And then cache memory. As I said, this is static RAM, static random access memory, and there are multiple level of caches. So inside for each core, for an example, let's say for quad core machine, there are several L1 caches for quad core, and there are separate L2 caches for level 2 caches for quad core. This is inside the processor. And L3 cache is outside the processor, but it is attached to the processor. That is also a cache memory. All three are static random access memories. Why SRAMs inside processor? Reason? Why you think? Why SRAMs inside processor? Any reason?
Because it's very small.
Until process, you have to remember the stuff, right? Okay, let's take example like this. When you have like when you are planning to eat bread, first of all you bring that from the shop. That is your secondary storage. Then you slice it. You will have like a slice of bread. Then these slices These slices, why you keep these slices in your plate? So one time, how many slices you take? Is it one slice or few slices?
One.
One slice. Plate in your plate, like, so it can, you can keep
In the
few
plate
slices.
we can feel. Yeah.
Can take
I
few
thought
slices. It's
eating.
like,
Yeah.
so you have the secondary storage. This will, we will learn this in paging, right? Paging kya concept ekak, operating systems. In that we will learn that. So operating system divide. So these large files, operating system, the large files, it will be in the secondary storage, which will be divided into pages and kept it something called a virtual memory. That's a virtual memory. You will store that in a virtual memory. You divide similar to that bread. You divide it to slices, and these slices you keep it in the desk. That is your virtual memory. Desk is virtual. Why?
Yeah.
After using, you will like clean the desk.
Yeah.
After your breakfast, after your lunch, or after your dinner, you clean the desk. That is temporary. That is your virtual memory. In your virtual memory, you keep in the desk. From the desk, you take to the RAM. Only the required pages, only the required number of pages, not everything, not all the slices, right? You take few,
Yeah.
select and take few, depend on your capacity. So RAM will take
Yeah.
slices. These slices, then when you want to eat, you will take one slice to the hand. Because slice that is like level 3 cache. You take one slice to the hand. Now you are going to process that. You are going to eat that. One slice to the hand. Out of that slice, you will take piece, small part. You will eat it. You will tear and eat it. So that is your level 2 cache. To process, you have taken one part of that slice. That teared one, then you have to break it to small pieces. Why? Otherwise, you can't process. Then you have to divide into small pieces and keep it underneath of your teeth or in between your teeth and eat. Process.
Yeah.
That is like your registers. That level is not
Oh.
there, right? Anyway, that is like your registers. So that's why you have a hierarchy of this bread, slices, bread, all the slices, secondary storage. That is also secondary storage. Virtual memory is also part of secondary storage. Then some slices, that is RAM, currently processing things. Then the required slice, the currently processing particular part, required slice, that is in the level 3 cache. Then the level 2 cache, processing, now processing. We are going to process now. And then the registers, the level 1 and the registers, that is small pieces that you have divided, that is for processing purpose. That is the registers. And that's why this is called memory hierarchy. When you climb up, it will be expensive to replace the teeth, so you have to pay high. But to replace
Yeah.
the bread, slow, right? So you can remember in that way, right? To replace
Yeah.
this, it will take, it's really high cost. So the registers, cache memory, high cost. Replace the mouth, jaw. It's basically high cost, at high cost in this level. But to replace the plate or replace the table, replace your plate, replace table. So it's not much expensive, right? Considerably less expensive. But this one is really fast, absolutely faster, but limited. Faster, your teeth digestion happens so fast, but limited. Limited means like you can't digest entire bread at a time, but
Yeah.
you can digest a slight, small piece. So that is the possibility. The capacity will be low, your capacity will be high, cost will be high, cost will be low, faster, slower. So those are the features in memory hierarchy. We will learn this lesson again in operating systems, but so this is the big picture of it, right? Okay, then here registers are special high-speed memories, so that is also there. And dynamic RAM is slower than static RAM. So DRAM can be seen as a separate unit. We saw cost of SRAM is very high, and DRAM can be easily replaced. But SRAM, can you replace? Can you replace your teeth easily?
No.
Can you replace your plate?
Yeah.
So that is the thing. So remember that example. That is a great example came to my mind. right? Anyway, it works well with this hierarchy, the memory hierarchy, right?
Yeah.
Okay, so then so what will happen? So basically, when you do something, what will happen inside the computer? I just gave some examples. This is like, so this is a separate course. We are doing this for after A-level students, but still this is relevant to A-level ICT. That's why I have taken this, right? So type in letter and take in a printout after saving. What will happen? Type in a letter. When you will insert keys using keyboard, it will go to the main memory, right? Because main memory is the place which takes everything.
Yeah.
It will go to the main memory. When you type, it will go to the main memory. And CPU will process that. Because computer doesn't know what letter is, right? Letters done in AI. So this letter, it's not letter to the computer. It's a matrix. It's a matrix. Why? When you zoom this, further and further, this is just turn on bulbs and turn off bulbs for the monitor.
Yeah.
Right? Status of turn on and turn off bulbs to the monitor. Different colors maybe.
Yeah.
That is how monitor recognize. How keyboard recognize this? It's a switch. For keyboard, it is a switch. So you can see physically, if you remove a key, don't remove. But when you remove a key, that's a switch. That's how keyboard recognize that. For keyboard, that's a switch. For monitor, this is a set of bulbs. So how you can tell that computer will recognize this? No. The switch to bulb conversion process. The switch should be, letter A switch should be converted to set of bulbs. That is done by the processor. That is done by the processor. Processor will identify these signals, which switch has turned on and what is the instruction given, and it will process and it will send to the graphical processing unit for further processing, and GPU then process and send it to the screen. And then you can see it in the output, in the monitor and the printer. And when you save it, it will go and it will be written to the hard disk.
Yeah.
So what is hard disk? Again, it's a magnetic disk. Hard disk cannot recognize letter A, but it can recognize magnetism, right? So processor have to take the responsibility of that. You have to convert that to the magnetism possible. So possible magnetism signals and send it to the hard disk. Then hard disk will magnetize according to the processor's instruction. Later, when you read, hard disk will demagnetize. It will send the demagnetized signal, that is a current signal. The magnetism will be converted to power, and power signal will be sent to the processor. Processor will process that and understand that, and it will open and load it to the main memory, and ultimately it will again process and display the content in the monitor as set of bulbs. Right? That is a complex process.
Yeah.
Who hides this complex process from us? When you type A will be there. When you type B will be there. Then who hides this complex process? So if these hardware components are working, it's utter complex. It's very complex.
Yeah.
But we can't see that complexity. When you type A will be there. When you type B will be there. Who does that? Who hides that? That is none other than your operating system.
OS.
Yes, OS. There is none other than the OS. OS will do the understanding part. It will provide the instruction to the different hardware to get this idea and process this and display as user's intention. So then it will be displayed according to user's interest.
Yeah.
That is the task of operating system, right? Therefore, we tell operating system is the middleman, or in the other way, we can say operating system is working as an intermediary between the computer hardware and you. Is working as intermediary between computer hardware and you. Okay, so there are different other examples. You can just try it, calculate average using Excel. What will happen in hardware level, and what will happen when you download a software and install it? What will happen in hardware level? Likewise. Yeah. So don't look at the note I have given that, but don't look at that. Try to understand that. And then different qualities of information, right? Yes. Hello.
Yeah, hello.
Right. Then the qualities of information. Qualities of information means whatever. So when you produce the information, you have to concern about these factors. So whether that information is accurate. So inaccurate information is useless. For an example,
Mm.
let's say you have published election results, but information you got, right?
Yeah.
So information you got is basically, um, so let's say election results, those are incorrect.
Mm.
So if it is incorrect, so then it's not useful. And if it is irrelevant, irrelevant means you got information and you got election results of, election results of what, let's say you want election results of Western province and you got election results of Southern province. And you are going to
Mm.
select maybe council members based on the Southern province results of the Western province. Can you do that? No.
No, no.
So it should be relevant,
Yeah.
right? It should be timely. Timely means, so let's say again examination results. Let's assume you will get examination results in after 6 years of the exam. After you facing the exam, after 6 years of the exam, you get your exam results. Then you will not remember whether you have done the exam or not. And that is
True.
useless, right? Basically, it should be timely. So when you do the exam, at least within certain time, within 2 months, 3 months, you should get the results. Otherwise, it's useless.
Yeah.
Cost effectiveness. And so again, take the same example. You can get the results of your A level. To get the results of your A level, so let's say your results are published in USA.
Mm.
Right? You have to go visit USA and see your results. Again, no one will be interested seeing results even, right? Right. So unless you extremely think that that is really useful to you, likewise,
Yeah.
otherwise you won't go. So, for an example, your grade 5 scholarship results, it's in USA. So, no, so your term test results in USA. You don't worry, right? Why? So you are not
Yeah.
going to. So you don't want the term test result. Okay, keep it, right? So likewise, sometimes even though it's relevant and information is timely and accurate, sometimes people will not be interested in getting that if it is costly. For an example, you know
Yeah.
that sometimes matches, so they are broadcasting in paid channels.
Ah,
So
yeah,
some
yeah.
people are interested, but some they don't care. Okay,
Yeah.
match is in this channel, so don't. So we can't watch. Just it, right? And
Yeah.
likewise, some will ignore. So
Yeah.
because the information should be cost effective and
Mm.
completeness. So completeness means you get part of this. Let's say you get part of this video, and so let's say part of this video is missing, or you get part of this note. Part of the note is missing. Then again you will have a problem. So how to find the next part? Without that, it is incomplete,
Yeah.
right? And the very important thing is you should not violate the subject's ethical privacy requirements. You should not violate subject's ethical privacy requirements. That is also very important, right? You should not
Yeah.
violate the subject's ethical and privacy requirements. So that means you can collect information, but this is like violated most of the times in Sri Lanka. So especially when reporting these COVID cases in the earlier stages, right?
Mm.
Media went to the home and tried to video and publish, saying so. It's like COVID. So if you are infected with COVID, it's like a crime, right?
Yeah.
In the initial stage, but so that was not good. People were hiding because of that.
Yeah.
Even
Yeah.
infected, they didn't come in front. So due to that, the secretly it was spreading to other people.
Mm.
Likewise, and so this is the thing, right? And you will so it's given unnecessary public publishing to that and given unnecessary highlights to that. So that is one reason. So where we suffer. Because of this unnecessary media publishing, what has happened, people were reluctant to come forward due to that.
Yeah.
So there was some study, right? So
Yeah.
here that that so that what do you call the Ammika penny and also give an unnecessary public. So likewise, unnecessary focus should not violate the privacy and should not violate the law. Especially, you have to think about that. Information is useful, yes, but without violating the parties, the related parties and their privacy, you should be able to disclose that. For an example,
Yeah.
right? For an example, this happened for girls. So normally, today in today's world, it is possible to capture. It is possible to capture a picture of girl without much effort, and it is
Mm.
not a big thing now. So you can't come against that because you have CCTV everywhere. When you go to shop, your video is there. When you go to
Yeah.
when you walk through a road, your video is there, your pictures are there. But that doesn't mean that shop owner has right to publish in the public areas. You
Mm.
can't get the pictures and capture that and publish in the internet. So can't do that.
Yep.
That is violating of privacy. So that is the thing. So privacy means so everyone has private things. Everyone has requirements. They don't want everything to be published. For an example, about a disease, about salary, about the income, maybe about the social status. So they were about the job. They don't want to publish sometimes. So those
Yeah.
things it is unethical and illegal to publish without their permission. That's all. Okay, so this is special fact that came to my head, and but anyway, this is also important. So, what is screen resolution? What is screen resolution? So, don't look at this. Just tell me what is screen resolution.
Number of.
Resolution is number of pixels. So basically, it's number of horizontal pixels and number of vertical pixels.
Vertical
Because
pixels.
yeah, I think I said that this is a matrix. Monitor is a matrix. It's a LED grid.
Yep.
But since it has very large number of LED,
Small.
yes, it's very small,
Very tiny.
large number. You can't see that. But if you see this using a lens, if you can use a
Yeah, you
lens
can
and
see.
magnify this, then you can see.
Yeah,
Right?
RGB thing.
Sorry.
It will be like some will be red, green, and blue thing.
Yeah. So you can just see the pixels. But earlier days it
Mm.
was not like that. Earlier days it's visible. So basically that is called dot pith. Dot pith means the gap between pixels. Earlier the old
Mm.
phones, if you have seen
Yeah,
old
yeah, yeah.
phones, so you
Yeah, yeah,
can
yeah.
see there's a black gap, black color gap between two pixels.
Yeah.
So that is dot pith. Dot pith is visible in earlier phones, but now like dot pith is like it's a nano or it's even less than that. It's pico or nanopixels gap. So you can't just see that in your naked eye.
Yeah.
But when you zoom it using a lens, you can see, right? Okay. Anyway, vertical number of pixels and horizontal number of pixels. Basically, what is the value? Typical value? Can you tell me typical value in HD monitor? What is the typical value?
HD 720p.
Sorry,
720p, right?
720. So basically, in HD, you should have more than 720. So full
FHD is
HD, you should have
1080.
more than
Yeah, that
1080.
is 1080.
Yeah, 1080, more than 1080. So 4K, it's more than 2600. I see. Yes,
3000 something.
yeah, closer to 3000. So likewise, there are different resolutions, different number of. Okay, here. So in my one, it's closer to 1800. Likewise, and
Mm.
vertically, it's around 1500. So that is the normal resolution. You can just go and see Apple menu, this Mac, the display. Yes, it is. Yeah. So now it's 1440 and 900. 1440, 900. It's not much. And display preferences.
Mm.
Sometimes you can increase this, right? You can go to the display preferences and no, it's not given. Color, color temperature. No, resolution here, no way to change that. So it's fixed here. Okay. When you have more pixels, you can show more details. So this image resolution, in the other hand, image resolution is number of pixels in the image. So here you can see if image resolution is 4000 by 3000, it is called 12 megapixel image, 12 million pixels, 12 MP image, right? 12
Yeah.
megapixel image. So can you, so if you magnify up to 100%, can you see this image in the monitor? If you magnify up to 100%, can you see this in the monitor?
Yeah.
100%.
100% only.
100% means you have 400. Here I have, so you saw that in my stream, I have only 1440. So that is the natural, which is given 1440. And I have 4000 pixel image. I can see only a portion in the 100% size, and I can only see a portion of that.
Yeah, yeah.
Understood? Because
Yeah, yeah, yeah.
it has only
Only
1440. Then
1400.
I have to
That's
reduce the size.
4000.
Reduce the size.
Yeah.
So that thing is there, right? The image resolutions are much higher than the display resolutions. So you will see, you will not be able to see the full resolution 100% image in the stream. But what you can do is you can reduce the size and see that. That is possible, right? So, but if
Yeah,
you
yeah.
have like 4000 pixels in your monitor, it's great, superb, right? So if you can see that much of pixels, so but it will be costly. Okay, so
Yeah.
then so the last thing is about ICT usages. Like this is I have just done this lesson, similar lesson but different way. So you said you can see database information, characteristics of data, accuracy, these things we discussed, right? And then so this data, why data information are used, we discussed. Then here you can see so usages of ICT, right? And the so manual, this one we have not discussed the manual and electronic methods of data processing. No. Abstract model of information, we discussed that. And then classification of hardware, we discussed. And classification of software, we didn't discuss, right? We have to discuss that. And here, steps in data processing, gathering, validation, processing, output, storage. Yes, we saw that. Right. So then data gathering methods, input devices and output devices, they are telling about that, and we have to discuss applications of ICT. That's why we are going to discuss now benefits and issues caused by the ICT, and that is this lesson. And
Yeah,
copyright.
we did that.
Sorry,
We did that.
we did that.
Yeah.
Right, right. So then we can finish with that. So benefits of ICT, these are the benefits. So
Yeah.
you can use ICT in any field. So you name any field, you can use ICT in any field. And not just that, and so there are some
Even this.
e-services,
Yep.
right? E-services like B, C, G, and E, business to customer, business to customer to customer, government to consumer. Likewise, there are different services, and we learn about that as well. Then, so then, and issues of ICT,
We did this
issues of ICT, right? Okay. So then, type of viruses. That
viruses.
is about this lesson. This is the first lesson, your fundamentals lesson, and the other way actually we have this in our course in the book. So anyway, I'll send a PDF of this to you. Right. Let's quickly discuss about the history part. Okay. History of the computer. When it comes to the history, actually computing history runs a long time. So it's even the computing concept was there even 5,000 years ago. The abacus is treated as the predecessor, or it's treated as the first kind of evidence for computing. That era is basically called pre-mechanical era. Before 1450, the pre-mechanical era. This is image of abacus, what kind of device that was. Still abacus is used, right? So that is the wonder.
Yeah.
So still
There's
abacus
classes
is,
also.
right? So, and in the mechanical era, So like 1642. So this Pascaline was introduced. It's like you can see, it's the first kind of computer, but this only calculated additions. So this does additions and subtraction. This was performed addition and subtraction only, right? Only addition and subtraction. If you want to divide, you can do that by subtraction. If you want to multiply, you can do that by addition. How? 2 into 3 is 6. 2 into 3 you can do other way, 2 plus 2 plus 2.
Yeah.
Right? Then 6 divided by 3 is 6 divided by 3 is 2.
2.
So what you have to do, 6 minus 2, again minus 2, again minus 2. That way you find the division. But other than that, there were no mechanism to do the division and multiplication. So this invention was half. Right? But later, so it was improved to different other levels. For an example, so this is a punch card. Punch card was like, it's like a paper or card. It has holes, set of holes. These holes were used to store data or calculations, even store patterns. So this is used as an input device. So some people telling this is storage device. That is also correct. No argument, because so if you punch this, you can store something. If you punch this, you can input something. That is true. Even as output, you can use, no? You can punch and give it back. So that is output too. So even input, output, storage, everything could be done using this punch card. And this was the tool in that era. That means in the mechanical era. So you can see this is a weaving machine, Redivian machine, weaving machine, but it uses a punch card. So this card is punch card. To store everything using punch card. So this then actually this time, after this time only the stored program concept was introduced. But this has used that concept, right? But for formally it is introduced later by John von Neumann. And these two people were really important. So this is Charles Babbage, who invented the concept of computing. He's treated as the father of computer. And Lady Augusta Lovelace, Lady Ada Augusta Lovelace, she is treated as the first programmer. So she has developed the first program, right? So here, father of computing. Charles Babbage introduced his analytical engine. That is only engine, right? That is not a vehicle, right? What I mean by that is engine is the concept. So computer engine is like processor, right? But engine was not used to create a computer that time. Engine was there. Engine engine computer right? This engine was introduced by Charles Babbage, and that is a programmable engine. Programmable engine that is called analytical engine. Later, he has introduced another pattern, but that engine was also not implemented. That is differential engine. Ekat concept එකක් විදිහට තමයි introduce කරේ, not as a fully implemented version. This analytical engine is implemented, but the thing is, it's only an engine. After 100 years of his invention, 1830 තමයි invent කරන්නේ. ඒතකොට යා මැරුණටත් පස්සේ තමයි. So here you can see 1939. So they decided to use this engine. Is Mark I computer. And after 1 year, right, so large gap. Right. Then Charles Babbage was working with Lady Ada Lovelace, and Lady Ada Lovelace suggested that this can be programmable and it is possible to write programs to this engine. So these were history, 1800. But in 1900, this engine was used in developing this automatic sequence control calculator, or ASCC, later named as Mark I. It is done by Harvard. Right. So this Charles Babbage and this university people, they together developed this one in 1939. Why suddenly in 1939?
World War.
World War. The reason is World War. Right.
Yeah.
That's why they expedited the development of computer. And you can see a lot of development that time, right? But
44, 47.
yeah, Mark 1, Mark 2, Mark 3, and then even Mark 4 with certain development. So invented that time during the World War period. Actually, that is for calculations. That is for do the calculations during that time and for researchers as well as the war purpose. But later, after the war, so there should be usage, no? They were really interested. They make a use they were interested developing this for researching purposes. And they have given this to universities and various universities. And even commercially, people were trying to produce computers. As a result, ENIAC, or Electronic Numerical Integrated Analyzer and Computer, was the first. It's known as the first electronic general purpose digital computer. So don't tell it's the first computer. It's wrong, right? ENIAC is not the first computer. ENIAC was the first programmable electronic general purpose digital computer. So if these words are there, yes. Otherwise, there are arguments like ABC is the first computer, ENIAC is not. But when it comes to first programmable electronic general purpose digital computer, ENIAC is the one. And see the size of that, right? So by 1956, this is after the World War, ENIAC has 18,000 vacuum tubes, 7,200 diodes, 1,500 replacement switches. It's like keyboard with 1,500 keys, right? Keyboard with, now you have 100 keys now. This is like keyboard with 1,500 keys. And 70,000 resistors, 10,000 capacitors, and 5 million hand-soldered joints. Atim passable joints, million pahak. Right? Think about the complexity and the size of the machine. It's a very large one. But later, so what has happened? Later, gradually, it has scaled down. Computers, this is fourth generation. Computers become small. Even it can be kept in a desk, on top of a desk. Now it can be kept in your palm, hand, wrist, right? That kind of small machine that is now. But earlier days, it was very large. Then the so VAC, mainly this VAC, EDVAC, UNIVAC, ENIAC, this belongs to the first generation, right? AC. But there are some second generations too. So UNIVAC is also introduced that time. And IBM 704, international first, that is a first mass-produced computer. So IBM can take international business machines. They want to do business with computers. So they have produced that in mass scale, the business level. For businesses, they have developed. And then Apple came to the business, that is like that is also after World War. And this is first, this is called Apple I computer, what was not much popular, but they have later developed that to Apple II computer. Right? They have later developed it to in 1976. Right? They have developed that to this is first Apple I computer, but later they have developed it to Apple II computer by 1984. So they have sold 6 million units, Apple II. 6 million units. Ekalit 6 million sold. So think about the selling capacity and the demand that they had. Right? The first generation. So there are like some arguments about the years. Don't think about the years, think about the technology. So what was used in first generation? Technology in first generation is
the machines thingy.
Vacuum tubes.
Yeah. Resistors, vacuum tubes.
First generation computer use vacuum tubes. Second generation? Second generation? Transistors. Third generation?
Capacitors.
IC, integrated circuits. Right? Please remember, I'll send this note also, right? First generation vacuum tubes. First generation vacuum tubes and use magnetic drums for storage. Actually, initial generations, the first generation, you didn't, so that time you don't see any kind of monitor. You won't see monitors because they have used printers initially for the output, not monitors,
Oh,
right? So they have used printers earlier. But second generation onwards, there are some monitors, screens. So the when it comes to third and fourth generation, screen was the elementary or the fundamental output is popular. Okay,
okay.
first generation vacuum tube, the second generation transistors, third generation ICs, and fourth generation, there were very large scale integration and large scale integration. So that is a theory part. So here the other
Okay.
things are common sense, right? High power consumption, cost was high, size is high, larger in size, solved a few problems and generating more heat. So here output got given to printouts. No difficult to program and control, not
Not
movable because
movable.
it is too large. So these are
Mm.
common sense, right? You can just write using common sense. So only you need only one. Other things can be generated because then
Yeah.
you can say the second generation quite small than the first generation.
So
Okay.
first is vacuum tube, second transistor, third IC, fourth.
Fourth VLSI and LSI. Integrated circuits in the third generation. Fourth generation,
IC.
very large scale integration, and here large scale integration.
VLSI.
LSI,
Fifth.
LSI. And in the fifth generation, ultra large scale integration. It's not mentioned here. It is ultra large scale integration, ULSI.
No.
Okay.
Yeah.
So, but other things are general. Other things general means
Mm.
right here, relatively very large in size. In the second generation, in second generation, you can
Bit
say
small.
relatively smaller than the first generation. High power
Yeah.
consumption, relatively low power consumption than the first generation. Cost was high, relatively low cost than the
Relatively
first
local.
generation. Less reliable, relatively reliable than the first generation. Right? Likewise,
Yeah.
if you have one node, other things can be generated. Solved only one
Automatically.
problem at a time. Solve many problems. Right. So input
Yeah.
was so these things you have to think, right? Input were given magnetic tapes, like these things you have to technically write. Other things you can generally write. Difficult to program and control. Easier than the first generation. Right?
Mm.
Not movable. Second generation is also not much movable. Not much movable. But third generation onward, it's movable.
Mm.
But these are second generation, right? You can see second generation computers like large disk. Still not movable, but can manage. Right?
Yeah.
It's not movable, but can manage, right? Third generation, when it comes to third generation, it's like this desk. Now, like computers are like desks. You can move. Right? When it
Okay.
comes to here, this is also third generation. So looks nice.
Mm.
So you know that earlier days when we access computer labs, we have seen like this kind of labs. When we access these labs, there's a unique smell that is related to computer labs, right? Unlike these days, there's a unique
Mm.
smell because of these devices, right?
Yeah.
Of these devices, now you can't feel that much because I think most of the time we have electronics everywhere now.
Yeah.
Now we can't distinguish between that. Basically, that
Yeah.
has happened to people. So when there are too many things, people cannot distinguish.
Yeah.
But earlier days, so if there's a small change, even people can
And fine.
distinguish. Like animals, people can distinguish. They had that sense. But with the
Yeah.
devices, with new inventions, the sense will be lower. We will be
Gone.
insensible. Some people are shouting that millennials are not bright. These are like machines. Millennials are not
Mm.
sensitive. They are insensible. That is true because the reason is they have drawn with the devices. Cannot blame them.
Mm.
That is their environment.
Yeah.
Their environment, they are drawn with the devices because your device will sense it. So why do you sense it?
Yeah.
Reason for sensing it. Your device, your timer, your alarm will tell it is 5 a.m. in the morning. So why you sense it?
Mm.
Your alarm will ring and tell you, right?
Yeah.
But earlier days, it's not like that. When it's 5 a.m. and people know that. When bird sounds are there, when this environment is like getting, so this light, so they will feel, now they will wake up and see. But now it's not like
Yeah.
that. Now your alarm will say, now it's 5,
I,
right? So that is why we are losing our senses due to these machines cannot help, right? We are drawing in
yeah.
such environment. So then, so the because of this autofocus in lens, you know that in near future, people will even lose their focus, right?
Yeah.
Eye focus, yes, because the so recent invention, the vehicles, these vehicles will become auto driving. You will lose the sense of driving there, right? So that is the dangerous fact of that. When vehicles become auto driving, you don't care. You will think vehicle will do that for you, right?
Yeah.
So likewise, you will lose senses. It's not developing yourself. It's developing the world. That is true, but it's not developing yourself. For
Mm.
sure, it's not developing yourself. It's ruining yourself, developing the world, physical things,
True.
right? Okay, so then, right. So there are some examples also given for this generation. And now we are in which generation? Fifth generation or fourth generation?
Fifth.
Yeah, we are in the fifth generation, but still we are using the technologies from fourth generation, right? So we have not completely given up about the fourth. Still we are using, because here C, C++, still we are using.
Mm.
Languages used in the third generation, still we are using. Here, this one also we are using. Right.
And
So we are in fifth generation, true, but we are still using some technologies from fourth generation. We have not totally given up on fourth.
mm.
Okay, so with this discussion, actually, since I have to go, I'll stop just before half an hour, right? I think we have done like on 1.5 hour lesson.
Yeah.
I'll stop from here. So then remaining part we can discuss in the Saturday as well as next Tuesday, right?
Okay.
Okay, then have a nice day. Bye.